Welcome to 4.4's video. Our lesson essential question is two parts. Can I test if a biconditional statement is true? And can I solve problems using the angle sum theorem, exterior angles theorem, and the mid-segments of a triangle theorem? So the first one is the triangle inequality theorem. It states that the sum of the lengths of two sides of a triangle is always greater than the length of the third side. So for a triangle to exist, these two smaller sides of 8 and 7 need to add up and be greater than the longest side. So if 15 is greater than 10, which it is, I can say that this is a triangle that would exist. If the numbers they're not bigger, like let's say 1 plus 2 equals 3, well then that is the same as this side, and you can see here how what hinge up and down, they would not connect here, and that would not be able to form a triangle. So here's a question for you guys to solve. So from these three sets of numbers, which would represent a triangle? Welcome back. So I'm going to need to do some math here. I see the longest side is this. So if I take 10 plus 22, I get equal to 32, and 32 is less than 33, so it is not A. For B, I can take 12 and I can add it to 15 and I get 27. 27 is less than 28, so it's not B. For C, I can take 6 plus 17 and I get 23, and 23 is greater than 20, so I think it's going to be C. There's only one right answer, so let's just check the last one. 13 plus 17 equals 30. 30 is less than 31, so this one wouldn't work, so the right answer is C. For these remote exterior angles theorem, we can take this triangle, and triangles add up to 180, and I can take this linear pair, and linear pairs add up to 180. So if I say 180 equals, and I'm going to make this y plus 45 plus 75, and then I make another equation, 180 equals y plus x, I can say, well, both are equal to 180, so let me just substitute the 180 out, and I can say y plus x equals y plus 45 plus 75, and then both equations have y on this side, so I'll subtract y from both sides, and I get that x is equal to 45 plus 75, which, if I just look at the triangle here with the exterior angle, back to my pencil, I don't need to add up to find what this angle is, which I could do. 75 plus 45 is 120. And then I could say, oh, it's 120 here. 120 minus 180 minus, that's going to be 60. Then I could say, well, 180 minus 60, because that's linear pairs, gets me 120. So x is 120 because I can use the shortcut of the remote exterior angles theorem. The remote exterior angle is x, and the interior angles would be 75 and 45. This 60 is a interior angle as well, but I'm not going to be using this one in my remote exterior angles theorem. So here's another one. I'm going to take these two angles, x plus 90 will be the same as 120, and I can work backwards. Rather than these two added together to equal this one, I'll use the same property to solve for an interior angle. Subtract 90 from both sides, x equals 30 degrees. So here's one that you guys can try from Delta Math. Okay, welcome back. So I'm going to have x plus 51 equals 76. This is my remote exterior angle, and these are my two interior angles. I'm going to subtract 51 from both sides. That cancels, and x equals 25 degrees. The next thing is the triangle mid-segment theorem, but to know that, we got to know what a mid-segment is. So a mid-segment is a line connecting two midpoints. So I can say VU is a mid-segment. And if it is a mid-segment, I know that it's the midpoint. So this is 6, SV is 6, and VT is 6. And then SU is 5, and then VUR is 5. This could also, this would be a mid-segment. If this is a mid-segment, which it can be, I would say that PW is 7 and WR is 7. So the triangle midsegment theorem is that the midsegment of a triangle is half the length of the parallel side. So I can find what VU is because it's parallel to this side of TR, and that's going to make VU 7. It's half of the parallel side. WU is going to be 6, and VW is going to be 5. Here's a problem that you might run into on Delta Math. Pause it and try it. Okay, so it says triangle NOP, which is this middle triangle, is formed by connecting midpoints, so that's going to be mid-segments. It wants to know what's the length of LM. So that's going to be this full side here. Well, the triangle mid-segments theorem states that the mid-segment is half the length of the parallel side of the side on the triangle. So this is half the length, so I'm going to take 8 times 2 and get 16. So that's my length for LM. Moving on to some more math stuff about numbers. So we've been talking about if and then statements. The converse of an if then statement is the result of interchanging the hypothesis and conclusion. So if I said, if you are tall, you can dunk. To make the converse, I would say, if you can dunk, then you are tall. So that's a converse. Now, not all the time will this be true. So going, I guess, to this one, some people are tall and they can't dunk, and some people are not tall, but they can dunk, but they're not tall. So in this case, both of these statements aren't true. Sometimes, though, the conditional statement, which is my first statement, is true. So if two sides of a triangle are congruent, then the base angles opposite of those congruent sides are also congruent. So these two sides are the same, then the base angles opposite would also be the same. So this is an isosceles triangle. I'm switching my converse and inverse. I'm switching my if and then to make my converse. Then I would say if the base angles opposite the congruent sides are congruent, so I'm starting with the congruent angles, then the two sides of the triangle are congruent. So in this case, both these things are true. And when both statements are true, then I would say the biconditional statement is true. So let's go and make another one. If a line is a mid-segment on a triangle, then it is half the length of the parallel side. So I'm going to switch this. Well, pause it and you switch it. Okay, so you should add something like this. If a line on a triangle is half the length of the parallel side, then it is the mid-segment of the triangle. And is this going to be always true? Well, let's test it. Let's make a triangle. And I'm going to say that this is 10, so I can make a line that is 5. And if I put it right here in the mid-segment, then that would be true. But it doesn't say anything that that side has to be parallel. It just says it has to be half the length of the parallel side. So if I took this line and I moved it, then my mouse is not wanting to move the line. If I move it and I still make it 5, well, this line is on a triangle, and it is half the length of the parallel side, but it's not the mid-segment. So in this case, the way I phrase this would not be a true biconditional. So to recap, our less than essential question, can I test if a biconditional statement is true? I'm just going to take the if and then, switch them around, and then if that's true, it's true. If it's not true, then it's not true. And then can I solve problems using the angle sum theorem? That's when triangles, uh, I realized I didn't cover that. Angle sum theorem is very simple. It is that all angles of a triangle add up to 180. So let's type that here. All angles in a triangle add to 180 degrees. Can I do exterior angles theorem? So that's going to be the two remote interior angles equal the exterior angle on the far side, and then the mid segments of triangle theorem, which is that this is the mid segment theorem. If a line is a mid segment on a triangle, then it is half the length of the parallel side. So let's get the Mathian delta math done, and good luck on that lesson essential check-in.